Welcome to ion concentrations. Here we're going to look at how to calculate the concentrations of individual ions within a solution. Now, when ionic compounds dissolve in water, they often dissociate into the constituent ions. So when we have an ionic compound like sodium chloride here, when we put solid sodium chloride into water, then they turn into the aqueous ions here. The AQ here indicates that it's aqueous, that means dissolved in water. And so we have a sodium ion and a chloride ion. That is, our sodium ion in the solid here, this guy, is paired with a chloride ion, whereas in the aqueous solution, we have our sodium ion and our chloride ion, and they're able to move around independently of one another. They don't have to stick right next to each other. So what does this mean for the individual ion concentrations? Well, it means that our sodium ion concentration is going to be equal to whatever coefficient we have here. So in this case we have a 1 because we only have one sodium ion here, because of course we don't have a subscript written here for sodium. Likewise, we don't have a subscript written here for chloride ion, so there's a 1 over here. And that means that whatever concentration we have for sodium chloride, we have that same concentration for sodium and the same concentration for chloride ions. If we had a different example where if we had, say, magnesium chloride, in this case, for every magnesium ion, we have 2 chloride ions, and that means that we would dissociate these into a magnesium 2+ ion and 2 chloride ions. And that would mean that now we have twice as many chloride ions for every magnesium ion. So if we had, say, 1 molar magnesium chloride in solution, we'd have a concentration of magnesium ions of 1 molar, but we'd have twice that, so 2 molar of our chloride ion. So let's look at an example. What are the sodium ion and chloride ion concentrations for 3.5 molar sodium chloride? Well, let's write out our equation. We have sodium chloride, and here I'm going to keep in the solid, and then we're dissolving that to form a sodium ion in the aqueous phase and a chloride ion in the aqueous phase. And so, because we only have a single sodium ion here, we only have a single sodium ion there, and again we only have a single chloride ion here, so we only have a single chloride ion there. And that means that whatever our concentration for sodium ion is, that's going to be equal to our sodium chloride concentration, which is then equal to 3.5 molar. And likewise, our chloride ion concentration is equal to our sodium chloride concentration, which is equal to 3.5 molar. And again, these two concentrations are equal to one another because we have equal numbers of sodium ions and chloride ions in the compound. That is, for every 1 sodium ion, we have 1 chloride ion. And they won't be equal if we have different numbers of ions in our compound. So now let's look at an example where we have different numbers in our compound. So what are the magnesium ion concentrations and chloride ion concentrations for 4 molar magnesium chloride? Again, let's write out our reaction. We have magnesium chloride solid being dissolved to give us magnesium 2+ ions in the aqueous phase and 2 chloride ions in the aqueous phase. So now we're going to have twice as many chloride ions as magnesium ions, and so for our magnesium ion concentration, that's going to be the same as our nominal magnesium chloride concentration, which was 4 molar. So our magnesium ion concentration is 4.0 molar. Our chloride ion concentration is going to be twice the magnesium chloride concentration because we have 2 chloride ions for every magnesium chloride formula unit that we dissolve. And that means that then that's going to be 2 times 4.0 molar, which then gives us 8.0 molar. So again, note that our chloride ion concentration here, 8.0 molar, is double our magnesium ion concentration because we have 2 chloride ions for every 1 magnesium ion that we get to dissolve. So what are the aluminum ion concentrations and sulfide ion concentrations for 0.5 molar aluminum sulfide? Well, again, let's write out our reaction. We have our aluminum sulfide solid, and we dissolve that to give us aluminum ions. And we know aluminum ions always have a charge of +3. And we have our sulfide ions, which always have a charge of 2-. And of course we have 3 sulfide ions and 2 aluminum ions. And that means that then when we go to calculate our individual concentrations for our ions, that means our aluminum concentration is 2 times our nominal aluminum sulfide concentration, which was 0.50 molar. So our aluminum ion concentration is 1.0 molar. Our sulfide ion concentration is 3 times our 0.5 molar. So that gives us then 1.5 molar. And so note that in this case now, we again have unequal concentrations, but each of those concentrations is larger than the concentration of the compound that we put in, because we're getting out 2 and 3 of our ions respectively.